This top polynomial up here, notice, is in the form that we worked with last cycle, right? So you guys know how to kind of do that one, right? What is the difference between this new one that I added down here and these guys up here? What term is missing? Good, the x term, so that plus 7x or the bx, whichever one. Okay, so that x term is missing, okay? So if I want to rewrite this, would you agree that I can write x squared plus 0x minus 25 and that be equal to this up here? Would you agree with me? I'm adding 0 x's, right? Okay, so now it looks like it's in a form that I can factor in, right? So I need the factors of which number? Good, negative 25. Okay, what are some factors of negative 25? 5 and, not negative 2, but negative 5, good. What else could I have? Good, 25 and negative 1, which means I can also have negative 25 and positive 1, right? I just need one of them, one of my factors, to be negative. Okay? Do you see any up on the board yet that could add together to give me a 0x? Good, if I add 5 and negative 5, those two would add together to give me 0x. So to write my answer, I would get x minus 5 and x plus 5, right? That looks familiar. Okay? And I'm done. All right, so there is a name for this special type. Okay? There's a name for it. So we have the difference of two squares. What is a synonym for the word difference? Subtraction. Good job, Lennon. All right, so difference means subtraction, okay? So if I look over here, a squared minus b squared, you notice we just did one of those. We had a squared minus 25, right? And I can kind of essentially think about taking the square root of each of those. If I took kind of like the square root of a squared, what would I get? Square root of a squared. Kind of seems weird. What would I get? A, right? Because my square root and my square would kind of like cancel out. Okay, what about the square root of 25 we just came up with? 5, right? Okay, so once I come up with these two, so my A and my 5, I want to think about writing the plus version and the minus version. So A plus 5, A minus 5. Okay, so that's what this is kind of telling us up here. Okay, so once you find the different, or the squares, right? So these numbers, like 25 is what type of number? A perfect square, good. Which means what? Yeah, so if I take the square root, it's going to be like a 5 and a 5, and they come out perfectly, right? They're pretty numbers, okay? All right, so let's go over here to this example. So first things first, I need to check if I have a difference of two squares. So first part, do I have a difference? For x squared minus 9. Do I have a difference? Yeah, because I'm subtracting, right? So I have my difference. I'm good there. Can I take the square root of x squared and it come out a pretty number? Yep, it just comes out as x, right? Can I take the square root of 9 and it come out a pretty number? Yep, it would be 3. Okay, so then they wrote over here x squared minus 3 squared. So you know that you need the plus version and the minus version of both of these terms. So you'd get x plus 3 and x minus 3. Okay. Let's go ahead and try an example together. So go down to number 1. Okay. Do I have a difference of two squares? That's what I need to check. Do I have a difference? Yep, because I'm subtracting. Can I take the square root of s squared? Yeah, what would it be? Awesome. Can I take the square root of 49? 7. Awesome. And I know I need a plus 7 version and a minus 7 version, and that is all I do. How are we feeling? 3, 2, 1. Okay. All right, go ahead and work. Actually, let's do number 4 really fast. Let's do number 4. I lied. Okay. Do we have a difference?
Yeah.
Okay. Can I take the square of every term? So can I take the square root of 4? What would it be? Awesome. Can I take the square root of g squared? It'd just be g, right? And finally, we already figured out the square root of 25 was 5. So if I were to write these, I know I need a plus version and a minus version. I know that my 5 is on the right side of that symbol or that operation right there. Okay. What do I do with that 2g? Good, I put it together and put it in front. So I'd get 2g plus 5, 2g minus 5. I am done. Okay. Go ahead and work on numbers 2, 3, 5, and 6 in your groups. 2, 3, 5, and 6. All right, let's look at number 3. So I have 16 minus x squared. Do I have a difference? Yep, because I have a subtraction sign. Good. All right, do I have 2 numbers that can be squared? Or square rooted, I guess I should say. All right, square root of 16. Good, 4, and the square root of x squared would just be x, right? So I'd get 4 minus x, 4 plus x, and I am done. Okay, awesome. Let's take a look at number 6. That one was probably the trickiest one I gave you. Okay?
I think there might be a question of why is it not x plus 4, x minus 4?
Okay. X plus 4, x minus 4 on number 3.
Like, why don't the variables always have to come first?
So the variables do not always have to come first because if I have 16 minus x squared, you kind of want to keep it in the order that is shown in the problem. Because what kind of happens is if you write, whoa, that was really good. If you write x plus 4 and x minus 4 and you try to distribute that out, you would end up with x squared minus 4x plus 4x, and then you'd end up with minus 16. So x squared minus 16. However, in our problem, if we were to rewrite this, we would have negative x squared plus 16. So our signs are flipped. Okay? So the variable does not always have to come first. My recommendation to you would be to just leave it as the problem shows it. Okay? So you can rewrite it and do some other stuff to it, but my recommendation is always leave it how the problem writes it. Okay? Does that kind of make sense? Why we can't do that? Okay. That was a really good question. All right. Number 6. Okay. So same thing kind of happens on this one. I got to make sure, even though I see that K and I really want to put that K out front, I'm going to leave it over there. That way I don't have to mess with stuff. Okay? So square root of 81. What would that be? Good, 9. Square root of 49? 7. Square root of k squared? Good, so that would give me my 9 minus 7k, my 9 plus 7k. Okay. All right. How do we feel about this section, 1 through 6? 3, 2, 1. Where are we at? Feeling pretty good? All right, let's go ahead and move down here. Okay. So this is super important. All right, so do I have a difference here?
Yeah.
Yes. Can I take the square root of 3? No. Okay. So now I got to kind of be a little bit creative about what I do. All right. Does anybody have any ideas? What is something I can do to this problem? Yeah. Do what?
Instead of having a square root, it just be like 1 factor.
Okay. Maybe. What are you going to say, Eric? Divide by 3? Okay, so what would that be called? What's our magic word for divide by 3? You're totally right. But why? Starts with a G. Good, it's my greatest common factor. So greatest common factor can still apply to these, okay? So if I take a 3 out, divide both terms by 3, that would give me, take my 3 out. If I divide this term by 3, my first term, what would I get? Good, m squared. And negative 300 divided by 3? Good, 100. All right. So now, can I take the square root of m squared?
M.
Good, m. Can I take the square root of 100? 10. And do I have a difference? Yes. So now I can write 3, and then I still get my m plus 10 and minus 10 pattern. Okay? So make sure that even on these ones, we can still look for a GCF, and that still might be something that we have. Okay? Let's look at 2 together, and then I'll turn you loose for 3 and 4. Okay? Is 8 a perfect square? Is 8 a perfect square? No. Okay, so let's see if I can find a GCF that I could take out that would make this a perfect square. So what should I try and take out? 8? Can I take out 8? Yeah, I sure can. So if I take out 8, 8x squared divided by 8 would give me just x squared, right? And 32 divided by 8 would give me a positive 4. Okay. Can I take the square root of x squared? Yep. Can I take the square root of 4? What would it be? Okay, do I have a difference? No. Uh-oh. All right, so I have to leave it with just the GCF taken out because I do not have a difference. That plus sign, think of it like a stop sign. You need to stop. You can't do anything else. Okay? All right. Let me throw something at you really fast. If I have, let's say I have 4x squared minus 16, right? 4x squared minus 16. Technically, I can take a GCF out, can't I? What can I take out? 4. Okay, good. However, what else can I do with this problem? Do I have a difference of 2 squares already? Yeah, right? So I can take the square root of 4 and get 2. Square root of x. Right? So I can get 2x minus 4 and 2x plus 4. So I want you to always make sure that you're looking just to do this step first. Okay? So if you don't have to take a GCF out, don't do it. Just leave it the way that it is. Okay? All right, go ahead and try 3 and 4. Take a look at number 3. All right. So can I take the square root of 16? Yeah. Can I take the square root of a squared? Can I take square root of 9? All right, so I'm good there. However, what's wrong with this? Good, it's a plus sign, not a negative sign. Wow, don't try and say that fast. All right, so what is something that I can do? Anybody come up with something clever?
I did.
Caleb, what'd you come up with?
Negative 4a plus 3 and 4a plus 3.
Negative 4a plus 3. Okay, so because we have a plus sign, we can't go straight to doing the difference of squares. What do we have to do first? We have to get that plus sign to be a minus sign. So how can we change signs? Good, we can divide by negative 1. That's tricky. All right, so negative 1 can be kind of like our GCF, so we want to keep it out front. So if I divide by negative 1, that would give me 16a squared minus 9, right? So now we can carry on. Square root of 16, you guys already told me was 4. Square root of a, you guys already told me was a. And then negative 9, we've got our 3. Okay, so our answer, we would leave 4a plus 3, 4a minus 3, but we cannot forget to put that negative 1 out front since we changed our sign. Okay, so if there's a plus sign, remember that's like a stop sign. You can't go straight to doing it. All right, let's look at 4. That was the tricky one. All right. Can we go straight into Just doing difference of squares.
No.
Why not? Why can't we go straight into doing difference of squares? Do I have a difference?
Yes.
Yeah.
But you can't find 3 fit for 50.
Right, so I cannot take the square root of 32 and the square root of 50 and it come out all nice and pretty. Okay?
Or into the third again.
Or really into the third. That doesn't really work out either. Or really n. So really the numbers just don't work. Okay? So all I have is a difference. All right, did anybody come up with anything to do here? Do you have something, Mariah? What'd you go with? Okay, good. So let's try and divide by 2. Okay, do I need to divide by anything else?
Divide by 2n.
Good. So if I divide by 2n, that is going to take care of most of my problems, I think. So if I divide by 2n, 32n cubed, divide by 2n, what would that give me? Oh. Take it one step at a time. What's 32 divided by 2?
16.
Good, 16. If I have 3 n's on top and I am canceling out 1 n on the bottom, I'm left with
2.
good, n squared. All right, what about the next part? 50 divided by 2 is? Good, 25. And my n's would cancel out, right? So I'm left with 16n squared minus 25.
I'll never remember how to do that.
You will. You just have to think about a GCF. All right. Now am I good? I have my difference. Can I take the square root of 16? Yes, right? Can I take the square root of n squared? Can I take the square root of 25? All right, so I'm good to go. So I'm gonna put my GCF out there. I know I need a plus version and a minus version. Square root of 25, you guys have already told me today, is 5. Square root of 16 is? 4, good. So I'm going to put my 4 out here. And the square root of n squared would just be n. So that would be my final answer. Okay? All right, good job. So I want you to pull out a blank notability note. Pull out a blank note.